either set notation or set builder notation. Now, I do not use set builder notation, I use interval notation. So, and most of your instructors, most of your math instructors is going to use interval notation. Now the difference between the two, if I give you a set and I tell you that I want you to write that set in a form that you can understand, most people are going to pick interval notation. I like interval notation because you actually read from left to right. Okay. 1, you read from left to right. 2 is simple. And 3, you don't have to write a big long sentence. It's short. Short and what?
Sweet.
Simple. Short and sweet. Short and simple, simple and short, whatever you want to call it. If I tell you that I want to write all the numbers in the set from -1 to infinity, then most of you know from the number line days, there's -1, 0, 1, 2, 3, 4. And I want to know all the numbers that are greater than or equal to -1. And you shade in that number line like this. And you shade in that arrowhead, which is called positive infinity. And you remember doing that back in whatever algebra. And then you were told to write a set notation of this answer. And that set notation could either be set builder notation, which is the algebraic way or the mathematical way of writing it, and then the practical application, which is usually the interval notation, read from left to right, would be -1 to infinity, and that would be your interval notation. Now I'm just going to cover interval notation. You need to know about set builder notation for the homework or for the test. Set builder notation would be just like writing your answer. X is greater than or equal to -1, and then putting an X such that in front of it. X such that, and then put braces around it. Now that's your set builder notation. Much more academic than the interval notation. Just put them over there.
Okay.
All right? And y'all get them, just leave me at least one piece, all right? All right, y'all go ahead, and if y'all want to go down and get something to drink, that's fine if you want to, but I'm going to keep on going. Go over to the bathroom, get you a napkin, that's your plate, all right? I'm not going to go into, y'all want pizza, there's pizza. All right. Just some things you might want to remember about set builder notation. And this is what you should have remembered when you first started set builder notation and writing sets and functions, is that when you have these two guys, I'll run in the same direction. You're dealing with an open circle or what? Parentheses. And when you're dealing with these two guys, you're dealing with what kind of circle?
A shaded circle.
Or a closed circle, yes. Or you're dealing with what?
Closed square parenthesis.
No, be quiet. All right, and one other note, negative infinity and positive infinity always get what? Parentheses. Now that's the stuff you should have learned back in Algebra 1, Algebra 2. I'm not going to spend time going over this because that's one of the first things that you should memorize when dealing with functions and inequalities. And most of the time, if you read from left to right, you won't get confused with it. I mean, I mean, we spend all of our life reading from left to right, unless you're from the Middle East, Masalama. And if you're from the Middle East, then you read from right to left. But if you're born and raised in the United States, which most of you were, or at least that you lived in the United States most of your life, you read from left to right. It always amazes me when students get to math and algebra, they start reading the graph from right to left. They start reading the equations from right to left. They start reading the set builder notation from right to left. When did we say in math that you have to start reading from right to left? But y'all start doing it. Not y'all in here, but just students. They just start reading from right to left. I give them a number line, and I shade it, and I go 0, -1, -2, 1, 2, 3, and I say, that right there, and I shade it. And of course, this is positive infinity. This is positive infinity, and this is what? Negative infinity. And I put this on a test. This is what students will write. 1 to negative infinity. And it just blows my mind. You have been taught to read left to right all your life. You get to math and you read what? Right to left. Why? Who told you to read from right to left? Some DA teacher, evidently, because it's not just one person, it's 4 or 5 of y'all out of a class of 30. Or, this is not, I'm talking about this class, I'm just saying. If I put 30 students in this classroom, and I put that on a test, 4 or 5 of y'all will put 1 to negative infinity, and I have no earthly idea why. And it just bothers me.
Okay, I won't do this, but I can see where they're, it's like there's maps on the wall. It says, you are here, you need to go this way. Like, I can see they're doing that or something.
Yeah, I could see that. But still, this is a mathematical sentence. It's a solution. I can understand that.
I'm just trying to get them all.
But, you know, 90% of the time, you read from left to right. So now that's correct, but it just boggles my mind. I would read it from negative infinity to 1. And a lot of people say, well, Hubert, what difference does it make? Well, you need to be what? Whatever you decide, you need to be what?
Consistent.
Consistent. You need to be consistent, therefore you don't get confused. I tell students read inequalities left to right and bottom up. Why bottom up? Well, most of you have walked down a sidewalk before, right? Most of y'all walk down a sidewalk. Walking down a sidewalk is 200 or 300 foot long. Most of you, in general, will look downward at where you're walking. Now, there are a few people that you know of that walk with their nose in the air, okay? But that's not you. There are people that most of the time they look down. And then when something happens, what do? You look up. Not many people do this, walking down the sidewalk and look down. Not many people do that. So your general is left of it, bottom up or left to what?
To right.
And thus you have the first quadrant. Okay? So most people do that, but I can see your point. That's the first person that I've asked that to you. The first person has actually said, you are here, and that makes sense. I never thought about that. All right, so interval notation is what we're going to use a lot of, but what do we use it for? Well, you're going to be dealing with functions. And functions is a 25-cent word for equation, basically. I give you 2 or 3 examples of functions. You tell me what the input is, an output, and tell me what the function is. Here's an example. One of your examples that I use all the time, of course, some of y'all may not know what this is, but some of you may. And I'm not an artist, so no need to make fun of my drawing. I know I'm not an artist. That's why I teach, okay? So some of y'all that are like Rembrandts and Michelangelo, whatever his name is, you can go jump in the lake, all right? That's still not, okay, let me put this here. Nope, that's wrong. There we go. And there, and we'll handle here. Now, most of you probably don't know what this is.
It's a garbage bin.
No,
Ice box.
ice, it's an ice machine. You used to see them a lot on every floor of what? The hotel. Now you just have the little dispensers that you take a little bucket. You have to take, it takes about 15 of those buckets to fill up the tub. Okay, just so some of y'all don't know that. A little bucket, it takes about 15 of them to at least get it halfway. But anyway, ice machine.
Trying to take an ice bath or what?
No. Some of y'all know what I'm filling up the bathtub for, some of y'all don't. That's all right. I don't need to specify, because if I specify, then somebody will say, Emmett was talking about this, and then my department head will call and say that I shouldn't be talking about that, so. We have some uptight people in the world. All right. What is the input for this function? Well, it's water. And the output is plain old ice. Now, let me ask you a question. What if I was to give you, in other words, I cut the water off, cut it off. Just take a saw and I cut the PVC or whatever it's called, just cut it. And I put a funnel on the end of it. And in that funnel, I tell you to pour, let's just draw a funnel. There we go. And in that funnel, I tell you, we're not going to pour water. I want you 5 gallons of cherry Koolaid. Then what will we get out? We won't get ice, we will get what?
Kool-Aid cubes?
We will get 5 gallons worth of cherry, what? Cherry, did I say cherry? I'm sorry, cherry, because I like cherry.
Koolaid.
And cherry and grape, that's kind of like cherry ice cubes. What if I say, okay, after that 5 gallons, I want to put, just forget about 5 gallons of cherry Kool-Aid, I want you to put in 3 gallons of lime Kool-Aid. And you put in 3 gallons of lime Kool-Aid. What will you get out of it? You'll get 3 gallons worth of green ice. What in the world does this have to do with functions? Well, your function is the ice machine, right? It's actually doing the job of turning the liquid into a solid, right? Everybody with me? But what a lot of people don't understand is, what does this depend on? This depends on what?
Cubes. I mean,
The cubes depend on what?
Kool-Aid.
The amount of Kool-Aid you put into the ice machine. So if I put in 5 gallons of Kool-Aid, I'm going to get 5 gallons worth of ice. If I put in 3 gallons, I'm not going to get 5 gallons worth, I'm going to get 3 gallons worth. So what depends on what? That's not rhetorical, I'm asking you. The ice depends on the water, so let's write that down. Ice depends, and I want you to underline the word depends, on the Kool-Aid, or whatever, the water. Alright, now let's go back, you can write that down somewhere to the side. Let's go back to what our ice is. What's a good word for the ice in this, since we got a function? What is the ice? It's going what? It's going into the function, right? So what could we call the ice? We could call it the
input.
The input. And what do you think the ice cube is going to be called?
Result.
The output. I was looking for opposite of input. The output. Well, that's still not mathematical enough, so we're going to take it down another notch. What's another word for input in reference to X and Y?
Domain.
You're stealing my thunder. You're going to fail this class. You know it. All right? X is our input, right? Because any function that we do, any function that we have, there's going to be what in there? It's going to be an X. And we put numbers in for X. And what do we get?
You get a Y.
You get Y. Now, the numbers that we put in for X can be called
The domain.
the domain.
I thought that's what you were looking for.
No, that's all right. You're already, this over. Sorry. No matter what you make on the test, might as well go ahead and drop. And the domain gives result to
The range.
the range. Domain. The range. So now we can say, because we are in algebra class, Y depends on
X.
output depends on,
Input.
and range depends on
Domain.
domain. You would not believe how many people are in college and have not made this whatever concept, have not understood, do not understand it, whatever the case may be. So therefore, what is this called? This is called the dependent. And this would be called independent. So have you ever heard of the dependent variable and the independent variable? Now you know. X is always the independent variable. Now, what if you have D is equal to R times T? Well, you're not going to be given two unknowns because you only have one equation, right? So you're going to have one unknown. So you're going to be given something. So you're going to be given T. Well, if you're given T, then T is your dependent and independent variable, and D is your what? Independent, because it's in the place of Y. All right? So I'm just telling you that's how that works. So if you're given a function, the function is going to be this guy. 2x plus 3. That's an example of a function. X squared minus 6. That is a function. 4x. That is a function. Then your x values are whatever you can use in that. Your y values is whatever is dependent upon that. Now you can plug in several things here. That's nice machine. January last year, my father passed away, and it was on January 13th, and the class started on 14th or 15th, it was something like that. And so I wasn't able to teach the first week of class. And my boss, department head, came in and taught my classes, the ones that she could, and one of them was a college algebra class. So she taught it for the first week, or the first week and a half. I can't remember how much it was, because I think we had Martin Luther King Day, so I didn't teach until that next Wednesday. And I came into class and I started teaching on functions, because she said she had went to the review. So, and she said I covered a little bit of chapter 1 or whatever chapter this is. And I came in and I said, okay, we're going to go over, but I'm going to make sure everybody's on the same sheet of music. And I drew this on there and I said, somebody tell me what this is. I wasn't expecting anybody to know. And of course everybody. It was like in unison. Everybody went, ice machine. And I went, what's going on here? there's not that many people that's a terrible drawing, okay? It was much worse than this, okay? And I said, okay, all right, I guess I got a bunch of smart kids here. So I went on and I drew another picture, and I knew I wasn't going to get this right because I couldn't draw, and it was a bunch of blocks, and everybody went, that's a hay baler. I said, well, wait a minute, and that's when I stopped. I said, okay, what? Y'all are not supposed to know that that's a hay baler. And everybody was snickering and laughing, and I said, how did y'all know that was a hay baler? We've already done this. And I said, how have you already done it? Because I have not taught it. She taught it. And what she had done is she had had one of my students, and she loved these, so she memorized them. She took that student that she had in trig, that was my college algebra student, and she stole my little ice machine in my
Hay baler.
hay baler. She stole it. But I thought that's a compliment. What is it? Flattery is, what is it?
Imitation is the greatest form of flattery.
Yeah, exactly. So I was like, what's the next one? She said, they said, bicycle. I said, that's sorry, she used all my little things. But anyway, I thought that was interesting that she did that. But a bicycle, I always use bicycle because, one, I can't draw it, but, you know, there's the handlebars, dang old seat. All right, shut up. I don't want to hear. If you want to draw it, you come up here and draw it, okay? Chain, dang old. All right, now, there's your bicycle. Input, output. Now, a lot of people say, well, you got to get on it. No, you ain't got to get on it. You have to what? What do you have to do in order for a bicycle to stay up?
Move it now.
You have to what? You have to move it. Yeah, I don't care if you're a good balancer. You can't sit there and, unless you just sit 2 or 3 hours a day and try to balance, you know, without moving. You might be one of those people, but anyway. In order for a normal person to balance a bicycle, it has to be what? Moving. And in order for it to move, you have to have some kind of leg power. All right? Or arms, depending on if you've lost your legs in the war or whatever. Because if you have a veteran, and I'm a veteran so I can say this, and they come home and they don't have the legs, and they're sitting on a bicycle, what's going to happen? They're going to fall over. Oh, but you're insensitive. No, it's called a fact. If you put a person that does not have legs on a bicycle, they're going to fall down because you have to have leg power. That input is essential. Essential. Just like the water. You can plug up an ice machine for 20 days. And if you don't have any water going into it, you're going to burn it up. Why? Because that motor is going to sit there and run and run and run until it does what? It burns out. Because you don't have any water going into it. But you can say that, but you can't say the no legs. Anyway, you don't have legs, you're going to fall down. All right? Period. If you put leg power in it, you get motion out of it. Same thing with the hay baler. Now let me ask you a question. What if you just are lazy and you just go half at it? Well, if you put half legs into it, what you going to get? Half motion. If you pedal as hard as you can for 2 hours, then you're going to what? You're going to get somewhere. If you sit on a bicycle and put your legs, and let's say you have legs, and you sit there and you put your pedal, your foot on one pedal and your foot on the other, and you don't move, what's going to happen? You're going to fall down. No leg power. Here we go. Well, this is my hay baler, so just go ahead and make fun of it.
bale of hay?
No, but the whole point is I'm drawing it. Dang old tire. Okay. Dang old.
What about the sexy tractor?
No, I don't know what you're talking about. I've never heard a stupid song like that, so I don't know anything else saying. Stupid people. Anyway, there's your hay baler. Now, some of y'all have no idea. Well, that's your parents' fault, okay? The hay baler picks up the grass that is cured, which is called hay. What's the difference between hay and straw?
It's cured.
No, straw don't have a head on it. Straw is just for bedding. Like, you want to, let's see, I don't know, some of y'all might have a calf, I don't know, some of you might not, a pig, whatever, you want it to lay, or a dog. Some of you may have a dog, and you put hay, or you put straw in its doghouse, so it has something to lay on. That's what straw is for. Hay has a head on it, you don't cut the head off, it's used for food.
They also use it to build houses, straw bale houses.
Yeah, the 3 pigs did, yeah, one of the 3 pigs.
No,
Yeah, but you can use straw to build houses with mud.
they're
and you
the
make
most
bricks.
energy efficient, actually,
Yeah.
and very.
We're not talking about that in here, okay? All right, so the grass, okay, the grass that you mow down, you let it sit for 2 or 3 days. If you have windrows are like rows of grass that looks like this, in other words, it's wide, and those windrows are very tall, then that means you got a lot of what? You got a lot of hay. So that means you're going to have a lot of what coming out of this hay baler? You're going to have a lot of hay bales. If you have a little bit windrows and some places there's not even any grass, then what are you going to get out? Very few hay bales. It's an old saying, you get out of it what you what?
Put into it.
And that's your domain and range. Now let me give you an example. Bicycle, dang old legs, fall down, grass, you don't have any, you don't get any hay bales. Ice, you got to have water to make ice. Let's take f of x is equal to x squared plus 4. Now, x is your input. X squared plus 4 is your hay baler or your ice machine. And your output is based on what? Your input. Let's say that in your universe, you're only allowed to go from -4 to +4. And I tell you that on the test or the homework, or the directions tell you that on the test or the homework. Can you use 5? No, you cannot. Can you use 7? No. You can only use from -4 to +4. So your world, there is no 7. There is no 14. There's only -4 to +4. So you go back to your pre-algebra days, because you're struggling, you don't know what's going on, and you want to make sure you get this right. So you go back to your pre-algebra days, and you plug in -4, -2, -3, -2, -1, 0, 1, 2, 3, 4. No, I'm sorry. That's reading left to right. This is what y'all do. 4, 2, -1, 0, 1, -2, 6. No, you can't have 6. 3 and 4. That's what y'all do. Another thing I haven't never figured out is why y'all do that. But you read left to right all your life. Don't understand this. There's no what?
There's no positive.
There's no there's no pattern. There's no anything. It's just,
Well, actually, there is a pattern. It's positive, positive.
yeah, it's screwed up is what it is. Remember, you don't exist.
See, you do it. You already know.
There's a method. to
No.
There is a method.
This sucks, okay? Don't do it. Don't do it. All right, so I put my,
Yeah.
what is this called?
Table of values.
No, it's
Oh.
called, starts with a D. Domain, this is your domain.
Oh, I thought you were talking about the whole.
Your domain is all the numbers from -4 to +4. It includes fractions, decimals, and whole numbers, but none of y'all use fractions and decimals, so we're just going to use whole numbers. And -4 squared is what? 16? 16 plus 4 is
20.
This is just not my day. 20. And that's going to be here, 20 also. -3 squared is 9. 9 plus 4 is
13.
2 squared is 4 plus 4 is 8. 1 plus 4 is 5. And 0 plus is 1. Now, that's pre-algebra, looking pre-algebra wise, make sure I didn't make a mistake. 1 squared is 1 plus 4 is 5. 2 squared is 4 plus 4 is 8. 3 squared is 9 plus 4 is 13. 4 squared is 16 plus 4 is 20. Make sure I didn't make a mistake.
Why did you put 0?
Yeah, what's 0 and 1 right there?
Yeah.
Why is it
Why is it not
one?
It should be a 4, I'm sorry, I thought that was a 1, my bad. I just make sure y'all wait. Okay, so. Graph it. Now, the reason I'm showing you this, I know all y'all know how to graph it, I know you know how to do it, but I'm trying to show you something, so bear with me. -4 and 20. 1, 2, 3, 4, and 20. Negative be 4, 1, 2, 3, 4, and 20. -3 and 13. -3, 13. +3, 13. 2 and 8. 2 and 8. 2 and 8. And 1 and 5. 1 and 5. 1 and 5. And 0, 4. And there's your parabola. Use your imagination. It's hard to draw freehand on this thing.
Gotcha.
Okay, now, this thing messed it up. Domain is X values only. I want you to highlight, underline, whatever, X values. So in this case, the domain is represented by this green line, which goes from -4 to what?